Hey, seventh graders, welcome to part C. The secret word or phrase is "what up, bro?" because that's what Kenny says to me instead of "hello, Mr. Sarley," like a normal professional child. We'll deal with that later, Kenny. But anyway, here are the answers. 1/2 is equivalent to 5/10 or 5/10. 1/4 is equivalent to 25/100 or 25/100, and 1/10 is pretty straightforward already. 1/5 is equivalent to 2/10, which is 2/10. 2/5 is 4/10. 3/5 is 6/10. On the back, 1/8 as an equivalent fraction is 125 thousandths, which as a decimal is the same, 125 thousandths. For the state test level questions, 1/3 as a decimal is 0.3 repeating, and 1/15 as a decimal is 0.06 with the 6 repeating. I actually haven't gone over these last two types of problems in class, but definitely going to be on the state test. So if you want to kind of see a tutorial for how to deal with weird fractions that go on forever, and maybe you're even wondering why is there some sort of line over this, then please watch because I'm going to go over all of it. Alright, so we're at a fraction decimal review page, and one important thing to remember with decimals is decimals are really just fractions. They're fractions that are as tenths or hundredths or thousandths, because that's what the place values are. So 1/2, if we want to make it into a decimal, first we have to find an equivalent fraction that has a denominator of tenths or hundredths. And since 2 times 5 is 10, I could multiply 1/2 by 5/5 to get 5/10. And then 5/10 as a decimal, that's literally a 5 in the tenths place, or 5/10. We can find equivalent fractions for many different types of fractions to turn them into decimals. So here's 1/4. 1/4, see, a 4 doesn't go into 10 without it being like a fractional part, but 4 does go into 100, because I know that 4/4 make 100. So if I wanted to find an equivalent fraction, I can make one out of hundredths. 4 times 25 is 100, because 25, 50, 75, 100. Make sure we're multiplying by 25 over 25, and we get 25 hundredths, which as a decimal is 25 hundredths. You could also have just thought about money, because for both of these, 1/2 is the same as 50 cents, and 1/4 or 1/4 is the same as 25 cents. 1/10, that's already in a fraction form as tenths or hundredths. So tenths are what decimals are based off of, so we don't need to change anything. We could just write it as 1/10. Alright, so to change 1/5 into a decimal, we got to say, well, can I write it as a fraction with a denominator of 10? And since 5 times 2 is 10, yes, you totally can. So I'm going to multiply by 2 over 2, and that's going to give us 2/10, which is the same as 2/10. Once we have 1/5, then basically we don't actually have to do any more multiplying. You could if you wanted, but if 1/5 is 2/10, then 2/5 should be 4/10, which should look like that. And 3/5 would be 6/10, which would look like this. You could have multiplied by 2 over 2 each time if you wanted to. But in class, and we actually have a poster of it now, Hector discovered that you can also think of 1/5 by thinking about money. So 1/5 is sort of like 20 cents. 2/5 is sort of like 40 cents. 3/5 would be 60 cents. He kept going. 4/5 would be 80 cents. And it works because 5/5 should be a whole, and it is. It ends up being exactly $1. So hopefully those made sense. All right, on to a trickier one. So 1/8 as a decimal is a little tricky to find because 8 doesn't go into 10 and it doesn't go into 100. So I'm going to use a strategy that a lot of you guys obviously did with Ms. Vicuña. We're actually just going to think of one 1/8, we're going to think of this line as being division. And we're going to do 1 divided by 8. You can always do that to find the decimal equivalent of the fraction. So to do 1 divided by 8, don't get confused with the order here. Whatever you're dividing up, which is the 1, goes inside the, I guess you guys would call it like a division house. And then we're breaking it up by 8, so that should go on the outside. And here's how you do decimal division. So 8 doesn't go into 1, and since we don't have any more digits in 1, I'm going to add the decimal point and put a 0 in the tens place. I'm going to bring that decimal point up over here. Now 8 goes into 10 once. 8 times 1 is 8. If I subtract that, let's see, I would get 2, because 10 minus 8 is 2. But I can keep going, so I'm going to put a 0 in the hundredths place, bring that down. 8 goes into 20. Well, 8 times 2 is 16, so we can do 2. 8 times 2, subtract 20 minus 16 should give you 4. We still have a remainder, so I'm going to bring down the 0. And then 8 goes into 40. Well, 8 times 5 is 40, so we should get that. And our remainder is 0, so we've done it. 1/8 as a decimal is 0.125. I'm going to put a 0 in front, but we haven't done this place value in class, but tenths, hundredths, after that is thousandth. So 125 thousandths as a fraction is 125 over 1,000. And now maybe some of you saw, it's a little weird to see, if we had multiplied the 8 or the 1/8 by 125 over 125, we would have got 1,000. But that's probably hard to find, which is why long division really helped us here. Alright, so the weird thing about fractions and decimals is that sometimes the decimal form never ends. Just would go on forever. And in math, we want to have some sort of easy way to represent that. A really good example is 1/3. So remember, 1/3, if we think of that fraction bar as being division, this is like 1 divided by 3. And all right, let's see what happens if I try to do 1 divided by 3. So I have the 1 on the inside divided by 3. Since 3 doesn't go into 1, I'm going to add the tens place, a 0, bring up my decimal point. 3 goes into 10 3 times, because 3 times 3 is 9. Subtract that, get a 1. All right, let's put a 0 in the hundredths place. Let's try it again. 3 goes into 10 again. Okay, that goes 3 times. 3 times 3 is 9. Gives us a 1. Wait a second. Let's just try it one more time to be sure. 3 goes into 10. Oh my god. 3 times 3 times 3 equals 9. And okay, by now you should start to see that this is something that's going to repeat forever. And it's interesting to think about why. It's because 3 doesn't ever go into any number that's 100 or 1,000 or any of those numbers. It doesn't go in exactly. So to represent this as a decimal, instead of writing 3s until you grow gray hair and die, because that's how long it would take, what you're going to do instead is you're going to do this. This 3, since it repeats endlessly, in mathematics we write this little bar over the digit 3. And that basically means 3 repeating. The 3 is going to repeat forever. So on the state test, if they ask you 1/3 as a decimal, what is that? What is that? They would actually expect you to write this, 0.3 with a line over the 3 to show that it's repeating forever. Let's look at one more problem, because it's going to repeat, but in a different way. Ugh, the answer is already on the screen, but let's divide it and find it ourselves. So 1/15 as a decimal using long division. Okay, so that's like 1 divided by 15. I can set that up with a 1 on the inside and a 15 on the outside. All right, here's what we need to be careful about place value. So I'm going to add the decimal point in a 0 and bring my decimal point up over here. But 15 doesn't go into 10, so I'm actually going to put a 0 here. And then I'm going to add a 0 in the hundredths place. Now 15 does go into 100, and it's a little weird to count by 15s, but if you were to do 15 times 6, you would get 90. So I'm going to put a 6 here because I'm trying to go into 100, and anything more than 90 would be too much. 15 times 6 is 90. 100 minus 90 is 10. Bring that down. Okay, so hopefully now you're seeing the same type of repeating is about to happen. 15 goes into 100 6 times. Multiply that out, we would get 90, and 100 minus 90 is 10, and this is going to go on forever. So this is how we would write 1/15 as a decimal. 1/15 is equal to 0. A 0 in the tens place, because that's always there, and then the 6 goes on forever. So I'm going to put a little bar over the 6, over that digit, to show you that it's 0.06 repeating. And that's how you would write 1/15 as a decimal. We're going to go over harder ones next week, because sometimes there are some weird numbers that will repeat like this. And then you have to write it as 2 digits, the 4 and the 2, that repeat forever. So it's actually not too hard. I just really wanted to show it to you guys so you're ready for it for the state test. Thanks for checking this out. I'll see you for the last video.